I hope you had fun on your quiz. Now let's learn to solve log and exponential equations. So we're gonna start here on the top of this page that's not numbered. And first we're gonna look at exponential equations. This should be a review from, from Algebra 2. A lot of y'all were doing this when solving for the x-intercept for the log graphs, which is so fun, or sorry, exponential graphs. So fun, so great. So let's review for those of us who forgot. So if I'm trying to solve for x and it's in the exponent, I want to create the same bases here. So my base is 5 and it's raised to the x. Well, I want this base to also be 5. So 5 to what power is 125? Well, 5 cubed, of course. When you have the same base, the bases cancel out. So your equation is left with x equals 3. Solve for x. Wow, so fun. This next one, the bases are already 3, but let's rewrite the square root, little guy. So the base is 3 to the x minus 4. Base is 3. If it's the cube root, that's 1/3. Bases cancel. You're left with x minus 4 equals 1/3. So now I just need to add 4 to 1/3. Add. That is 13/3. So we're just creating the same base and solving for x here. Let's do one more. Let's make a base of 5. So 3x. If I want this base to be 5, and I want 25 to be in the denominator, that means my exponent is negative. 5 squared is 25, so we'll have a -2. Your common bases cancel. You have 3x is -2, divide by 3. So that is solving your exponential equations. The next piece is with the calculator. We're not going to go over that. You know how to type things in a calculator. So let's look at solving log equations now. We did this whenever we were solving for the y-intercept for logs. So if I'm trying to solve for x and it's within this log, I need to rewrite as an exponential. So remember to circle the base, go across the equal sign and back around. So to rewrite as an exponential, we have 4 to the 3rd power equals 5x minus 1. And then you're doing your basic algebra from there. 4 cubed is 64. Add the 1. Divide by 5. Nice. Okay, let's do this one over here. We're going to rewrite, circle the base, go around. So I'm going to rewrite it as 2 to the 5th power equals x minus 6. That's 32. Add the 6. X is 38. Okay. Ooh, over here we have natural log. All that means is that the base is e. Well, I have some extra guys chilling here. We can divide by the 5 first before we rewrite it as an exponential. So 10 divided by 5 is 2. If I want to look at the base, it looks like this. So that's e squared equals x. E squared is a number. So I'm done. I solved for x. Okay? Again, let's divide by that 2 first. So divided by 2, that'll be 4. I'm ready to rewrite as an exponential. So e to the 4th power equals x plus 4. I still need x by itself, so I'm going to subtract the 4. Yay! I'll leave these guys for you to practice with, and I'll post the answers to those on Schoology. But now let's flip over to solving some more log equations that are a little more tricky. So for these, you have a log on both sides of the equation. We are going to be checking for extraneous solutions. So whenever we're solving an equation where we have to factor and we get 2 answers, we have to check which ones work. An extraneous solution is an answer that doesn't work. For logs, you can't take the log of a negative number. So if you're getting an answer, sorry, I'm shaking this table. If you're getting an answer where you're taking the log of a negative number, that answer is not gonna work. Okay, so right here, we have log base 5 on both sides. Now we're gonna follow the rule that you've been doing all of your mathematical life, where what you do to one side of the equation, you have to do to the other side of the equation, and then all is fair. Since my base is 5, I'm gonna create an exponential for both of these. So these two log equations are now the exponent of the 5. I do this because if I have an exponential and a log together with the same base, they can cancel. So I'm left with 5x plus 9 equals 6x. And that's much easier to solve. Subtract the 5, you're left with x equals 9. And that's it. So the goal is here, you need one log on each side. Make sure they have the same base, cancel the log, solve. So number 13, we have a natural log on each side. Her base is e to cancel. So 4x minus 7 equals x plus 11. Subtract the x, add the 7, so x equals 6. Cute. Okay, let's keep going. Right here, still again, raising to the e, so these cancel. X plus 19 equals 7x minus 8. Let's subtract the x to get 6x, add the 8 to get 27. So x is 27 divided by 6, which simplifies to 9/2. Cute. I'll let y'all keep practicing on those, but let's do ones that are a little more complicated, where I have more than one log on one side. So I can't just go through and cancel out all these logs. In order to cancel, you're raising it to the power, so I only need one log on each side. So that takes us back to our log rules that we learned last class. So if I'm gonna rewrite this as 4x minus 1, because this side only has one log, to create one log here, we have to remember addition condenses, excuse me, oh my gosh, am I going to have kids in my class? Yes, I don't have time for this. Addition turns into multiplication. So I'm going to have log, and now I need to multiply these two. Don't forget to distribute. So 2x plus 2. Now I have a base of 10 that I'll use to cancel these. So 4x minus 1 equals 2x plus 2. Let's solve for x. 2x equals 3. X equals 3/2. Okay, wow, I have to teach a class now, so I'm going to upload a part 2. Bye!